All right, so this question is about confidence interval, and I'm going to try to do it using the calculator. All right, so it will cost us less work, less time, and hopefully we get the right answer. All right, so please try to read the question and then stop your this video and try to do it on your own. This will be the best way to do it. Again, so let's see what the information. So what we have here is a hospital noise level, right? So the noise level at the various area urban hospitals were measured in decibels, right? The mean noise level in 173 ward area was 51.5. So what I understand from here, this means I'm doing a sampling. So the N would be 173, all right? And the X bar after measuring the 173 areas, it come up to 51.5 decibels, right? So that's the X bar. The standard population deviation is 4.2. So this is for the 173 again, the sigma X bar. And what we want to do is we want to find the 90th percentile confidence interval of the true mean. All right, and then they're going to tell you here, round your answer to at least one decimal place, one on the left, one on the right. So the best way, again, I think, is to do graph to see what you are doing, right? So now, again, I need to draw my environment here. This, I know I am working with X bars, all right? The mean, which we don't know it, but we know X bar, is going to be equals to 51.1, I think, 51.5. And sigma X bar again, this is, remember, I am doing sampling. And the N is going to be 173. So the X bar is whatever sigma they give you, the standard population. The population, they say population, so for the X bar, for the excess, all right? So standard population, you're going to take the sigma divided by the radical N. So 4.2. So this is going to be a 4.2 divide 4.2 divided by radical 173. All right. So this is the central limit theorem. If you forgot it, this mu X bar is going to be equals to the mean, all right? And sigma X bar equals to sigma divided by radical N. That's what I just did right now. So this is my environment. This is what I need to feed the calculator. I want to tell the calculator that I'm working in these conditions, right? So yeah. Okay, now what I want two boundaries of that contains the 90 percentile. So what does mean? If I have 0.9000 here as an area between two boundaries, I'm going to put the boundaries here. This is the boundary and this is the boundary. I'm looking for this boundary. I'm looking for this boundary. All right, that will cover this area in the middle. And this is going to be the 90 percentile. All right, so 0.900 in here in the middle. So if this total area is 90%, what will be my value in here? What will be my value in here? All right, so this is the thing that we're going to be using here on the calculator is called inverse. Would be called inverse normal. All right, so how do you get the inverse normal? And then we're going to go to what you need for the inverse normal. So first of all, you need to go to second and vars again, and the function is the third one. You see it here is inverse normal here, and as soon as you open this, you're going to see the area. You can ask you for the mean and sigma. All right, so the area is always the left tail area. What does mean? If I am looking right now, if I'm looking for this number in here, if I am looking for this number in here, the number that you see it here, I need to feed the calculator this area from this side. All right, so probably I should use different color. So I need to give the calculator, I need to feed the calculator this area that bounded in here. All right, okay, so I need to know what the area in here, this tail, or the calculation is easy. It's not really difficult. What you need to know, if I know this is 90%, so the remaining are going to be 1 minus 90%, that's 0, 1. So what this means, 0, 1 are going to be fed to this calculator here, 0.1 from both sides, this tail and this tail. They are both 0, 1. So the area in here would be that 0, 1, which I get 0, 9. All right, minus 1 minus 0, 9, and I just have to divide by 2. So in other words, this is the formula for this. It can be 1 minus the confidence interval divided by 2. All right, this is your formula. How do you get the area? And this is going to be 1 minus 0, 9 divided by 2, which is going to give you 0.05. So this is the area that you are looking in here, 0.05, and that's what you need to give the calculator. So I'm going to type in 0.05 in here. So the mean, you have the environment 51.5, 51.5, and you're going to go to the sigma and type the sigma as it is, 4.2, no sweat, you don't need to calculate it beforehand, divide by square root, so second and square root here, and 173, close the parentheses. So the calculator, we know the environment, and done. So 50.97, if you round it to one decimal place, you're going to be 50.51, it would be 51. So that's going to be your first value. The value here is going to be 51.0. That's what you're looking for. Yeah, apologize, it's a little messy here, but that's what you're looking for, is this value over here. That's 51.0 after rounding. Okay, so that's the lower bound, 51.0, 51.0. Now I'm going to look for the upper bound. So the upper bound is going to be exactly the same thing. Now, I need to feed the calculator the left tail area. I'm working in here right now. So in order to get this, I need to feed the calculator the total area on the left side. So if I have to do this, this is going to be my left area. This is it. All right. So if I plug in this area, remember this is 0.9, and remember this is the area in here is 0.05. All right. So the area here is 0.05. So what I need to do, I need to add them up together. So this and 0. So I need to add 0.05 to this. All right. And that's basically it. I keep the same environment. So I can even go to the same formula, enter, and go inside the formula, edit it. And do you see here I have 0.05. If I add 0.9 to it, it's going to be 0.95, and that's it. Enter. So this is the second boundary, 52.02. We round it to one decimal place, it's going to be just 52.0. So 52.0. confidence interval, round your answer to at least 1 decimal place. So if you want to keep it that way, or if you want to round it more, probably I could even round this one to 9.7 to this one, and I can at least 1 decimal place. The answer is correct, by the way, I think so. And this one, if there's 2 decimal places, I can put 0.3. So it's up to you. We want to do 2 decimal places, 1 decimal place. As long as more than 1 decimal place, we should be okay. All right, done with